Hey guys! Today I'm filming from a different spot than I normally film my videos, and I'm filming on my computer rather than on my phone, so I don't have the app on this computer to do the video editing that I normally do on my phone. So anyway, here I normally have that title slide with the music and everything. Here we go. So anyway, today's video is about limits because I've been taking a calculus refresher course just to kind of get back in the swing of calculus so that way I can tutor it during the school year. And limits is the biggest chunk of the class. It's not the majority of the class, but out of all the different chunks of the class, limits takes up the most attention. And it's also the first thing that you learn in calculus. It's the last thing you learn in pre-calculus, and it's the first thing that you learn in calculus. And so it's a pretty big deal. And with it being such a big deal, I feel like sometimes we get the idea that, oh, it's going to be really, really hard. But it's not. It's not. It's so easy. And so I wanted to make a video to just show you how easy this is, and that sometimes we get ourselves into the trap of overthinking it and thinking that it needs to be hard just because we put so much attention into it. But it's not. It's easy. It's easy. And so this video is going to tell you why limits are so easy, and then I'm sure that at some point I'll make other videos that show you some of the more intricate details of them, but they're so easy at their core. They're so easy, and that's what I want to show you today. So this is how we write limits in math, and I don't want to keep having to write this over and over because that's just a lot of effort. And so anyway, I just thought I'd show it to you and then say how you say it, and that way when I say it, you'll know in your brain how that would have looked on paper. So this is read as the limit as x approaches c equals y. So they're basically some number here. That's going to be the number you look for on the x-axis. And then this number here is the number that you look at on the y-axis. And you know how all points have an x-y coordinate? This is the same thing. The limit basically has an x-y coordinate. It has the x coordinate and it has the y coordinate. So the limit as x approaches, and then whatever number I say will be the x coordinate, equals, and then whatever number I say after that will be the y coordinate. Easy, right? Right? It's just points. It's just x-y coordinate points, just written out all beautifully fancy so we can feel really, really intelligent when we write it on the paper, because, you know, the more complicated something looks, the more you're like, oh, I'm so smart. And that's really what this boils down to. You are smart. You are. But limits are really easy. Okay, let's take some examples. Let's find the limit as x approaches 2. Easy. X approaches 2. What is y? So find 2 on the x-axis. Where is that on the y-axis? What is that? 1. So we would say the limit as x approaches 2 equals 1. Easy, right? Yes. Yes, it's easy. This time, let's find the limit as x approaches 3. Okay, so look for 3 on the x-axis. There it is. Trace that up to find it on the graph, and then figure out what that is on the y-axis. I meant for it to be a 3. Now, that's a hole this time. It's not a point, but that's the one special thing about limits. They don't have to be points. They could be holes. And so in this case, it's a hole, but the limit as x approaches 3 equals 3. Huh. It's still really easy, and it's easy, right? If I hadn't told you that I was teaching you something new, you'd think we were just talking about common sense, because we kind of are. Same picture as we had a second ago, but this time I just added a dot to it. So what's the limit as x approaches 3? You go to 3 on the x-axis, and you're like, is it the dot or is it the whole? For a limit, you want the part that's included in the little line that's called the graph. So in this case, we would want to say, just like we said a minute ago, the limit as x approaches 3 is 3. Easy. I thought I'd give some attention to the negative side of the x-axis now, since I hadn't been using that yet. And I also threw in an asymptote. Now, if you're headed into calculus, you know by now what an asymptote is. Okay, so anyway, what about the limit as x approaches -3? Well, it looks like when you're at -3, you just have 2 arrows that are both headed up, which we would call positive infinity. So the limit as x approaches -3 is positive infinity. And then I just changed that same picture just a teeny weeny bit. What about the limit as x approaches -3 now? Well, here's -3. But if you look at it, one of the arrows at -3 is going down, and one of the arrows at -3 is going up. And you're like, so what do I say? Well, there's not much you can say. The limit does not exist. Power. Oh my gosh, that's so inspirational. The limit doesn't exist, guys. No limits. Wow, that's awesome. Speaking of inspiration, I want you just to believe in yourself for a second. And just believe that you can mentally turn the lights on this rainbow. Are you ready? 1, 2, 3. Since I already had this graph, I just went ahead and threw in a horizontal asymptote, and I thought we could talk about the limits at infinity. The limit as x goes to positive infinity. What is the limit as x goes to positive infinity? Well, positive infinity for x would just be all the way to the right. And what's that little arrow doing all the way to the right? Well, it looks like it's pretty much flattening out at 1. So the limit as x goes to positive infinity equals 1. Also, we could just do negative infinity while we're here. If I ask you for the limit as x goes to negative infinity, on the x-axis, negative infinity would be all the way over on the left side. And so the limit as x goes to negative infinity, what's that arrow doing? That also appears to just be flattening out at 1. Very nice. Now you are able to talk about end behavior with limits. One of the very last concepts I want to talk about is limits coming from the right and limits coming from the left. So I've just thrown in same little limit notation here, but I've thrown in the plus and the minus. If I have the limit as x goes to c, and then there's a little plus sign up here, that means I'm asking you to find the limit as the line comes in from the right-hand side, as the graph comes in from the right-hand side. If I ask you for the limit as x goes to c with a little minus sign above it, then I'm asking you for the limit as the graph comes in from the left-hand side. Now, this plus and minus is just asking you to trace the little line or curve or whatever the graph is. It's just asking you to trace it in from the right or from the left. It has nothing to do with positive or negative numbers. Like, it's not saying like, oh, if you see a 3 and then you see a negative, it's not saying -3. It's just saying 3 coming in from the left-hand side. So anyway, let's just talk for a couple minutes about that. And so I made this little picture here, and let's talk about the limit for 1. Okay, now there's 3 questions we have here. What is the limit as x approaches 1, and then the little plus sign? So as x approaches 1 from the right-hand side. Okay, so if you trace this line in from the right-hand side, the place your finger ends up at, where x is 1, it ends up here on this hole. And remember, holes are okay for limits. They're totally okay. So it ends up on this hole, and that hole's at 3. So the limit as x approaches 1 from the right-hand side equals 3. What if they said, find the limit as x approaches 1, and then they had a little negative up there in the corner? That means look at the line as it's coming in from the left-hand side. So as you trace the line from the left-hand side, going towards 1 on the x-axis, where is it that you end up? You end up at this dot. Dots are also okay. So the limit as x approaches 1 from the left-hand side is 1. Okay, so from the right-hand side we got 3, and from the left-hand side we got 1. So taking the plus and the minus sign back out of things now, the limit as x approaches 1, and they don't tell you which direction it comes from, what does that equal? Well, it's the same as before, where the little arrows were pointing in different directions on the asymptote. Same as before. I don't know if I should say 3. I don't know if I should say 1. So what do I say? The limit does not exist. And don't forget, you were able to light up that rainbow with your mind because there is no limit on the power of your brain. Last thing I want to do is just a plug for my other videos and also for myself. I could have done some tables in this video, but when you really think about it, if I gave you a table and asked you to find the limit on a table, that's really just giving you the numbers that maybe you could just make a graph on your own and then look at the graph. Or if you're really good, you can just look at the numbers and you can be like, oh, I already know what the graph would look like. I don't have to put that on paper. But tables and graphs, it's the same thing. It's the same thing. So if you get a table, either just think about it with your brain, or on the other hand, you could graph it. If worse came to worse, you could graph it yourself, kind of sketch a little graph, and then find the limit that way. I also forgot to put in the plug for my videos. Hey, probably eventually at some point, I'm also going to make videos about what happens when you need to find the limit algebraically as opposed to having a graph in front of you. So I'll make videos for how you find it with factoring, how you find it with rationalizing, how you find it, oh, if I get brave, with trig identities. And I'll talk about my tricks and tips for like figuring that out, maybe even a little bit quicker than the official way. I don't know. But I also wanted to say, if you need tutoring, you can contact me on my website. And like I said, I'm not doing this on my phone, so I don't have the video editing software that I have on my phone, but you need some outro music. So here we go.